Hello guys, I hope you are doing good. My name is Ranjan. In this video tutorial, I am going to teach you about sorting algorithms in data structures. So before we learn about what is sorting and the different types of sorting algorithms, let me define you what is data structure. A data structure is a specialized format for organizing, processing, retrieving, and storing the data. In simple terms, a data structure is a storage that is used to store and organize the data. Now, as I said earlier, let us understand the different sorting algorithms in data structure. So before we learn about the different types of sorting algorithms and how to use those sorting algorithms, let us understand the importance of sorting with this simple example. Let's say there is a guy name called Alex. So this guy whose name is Alex currently is doing masters in IT. The good part about this guy is he likes buying textbooks. So even when he was doing the undergraduate, every semester he used to buy the textbooks. So the bad thing about this guy is this. So in their house there is a big storeroom where he used to keep all those textbooks. But as I said that the problem with this guy is yes, he likes buying textbooks. After the semester, he will go and throw the textbooks here in this storeroom. So in short, this storeroom is full of textbooks. So every semester, he buys textbooks, he will throw them there. By the time when he was doing the masters, there is a semester where he was going to learn about the data structures. At some point, he realized that he did data structures in his undergraduate. So he thought of using that book instead of buying a new book. So what he has done, he went into this storeroom and looked for that book. Unfortunately, remember, he didn't store those books in any order. So every semester he buys books and throw the books into the storeroom. So now he went into that room and looked for that book. You know what? He spent almost the whole day looking for that particular book because every semester he just throw the books into that room. So the big mistake that he has done, instead of storing that book in a certain order, so when I say it's a certain order, let's say, okay, this is my first year book, let me arrange them here. This is my second year book, let me arrange them here. This is my third year book, let me arrange them here. So when he was doing the masters, let's say for example, he is looking for the data structure book. If he could remember, oh, data structure, I did it in my undergraduate second year. So in that case, he would have just gone there and picked the book. Now the room is a mess. He was just busy throwing the books here. So he had to go through the room the whole day for him to find that data structures. As a result, he has wasted the time, he has wasted the energy, and he has wasted some cost. When I say that, how come he has wasted some cost? Let's say, for example, if he had arranged that books in a certain order, he would have gotten that book within a few minutes. Maybe he would have gone out and did something to make money. Now, instead of doing this one, he was just throwing the books into this storeroom. As a result, he spent the whole day, whole time, and even it involves the cost, right? So it is very important for us to store the data in a certain order so that we will have an access to it. So now what is sorting? A sorting simply means the arrangement of data in a preferred order. Why? If you arrange the data in a preferred order, when I say preferred order, it can be in an ascending order or it can be in a descending order. When you sort the data in a certain order, it is easier to search through it quickly and easily. So that's the reason why when you go into the sites, let's say for example, you are going to the e-commerce sites like this. So let's say you are trying to buy some hoodies and then you wanted to find out about the quality of these hoodies. In that case, I'm sure that almost all the e-commerce sites this time around, they would give us an option to sort the product based on different things. So let's say I wanted to sort this product based on the customer review. So in that case, here you can go, there are ratings there. Let's say I wanted to buy the quality ones. When I say quality ones, I wanted to buy the product that has the highest star, or maybe the most stars. So in that case, you can go and sort the products. In that case, it's going to give you the products that are being rated high by the users or customers. Or if you wanted to sort the products based on the price, here is a thing. So let's say I wanted to sort the products based on the price like this. So in that case, it's going to sort the product based on the size. So now, because of this sorting, it is making our life easier. In that case, we can sort, or maybe we can search the product quickly and easily. So this is why we are saying sorting is very important. Now we are going to understand. Remember, I say the data structure is simply means how to store and organize the data. Why? The way that we store and organize the data, it determines, it will help us to have an access to that product, isn't it so? So if you wanted to have a quick access to a product, you have to organize the data. When you store the data, you need to organize the data in some way. Not like this guy Alex, who used to buy the books and then just he was busy throwing the books into the storeroom. When he was busy looking for a book name called data structure, he had spent the whole day just to look for that particular book, because he did not arrange the book in any order. So sorting is very important. So in data structure means we are how to store the data and organize the data, right? So data structure has got different sorting algorithm. Here we are going to look at few sorting algorithms, that is bubble sort, insertion sort, selection sort, and quick start sort. So apart from these four sorting algorithms, there are different sorting algorithms that can be used. So now for this particular class, I'm going to explain you four different sorting algorithms that can be used in data structure. The first sorting algorithm is a bubble sort. So what is bubble sort? Bubble sort is a simple sorting algorithm in data structure. When you use the bubble sort, it's basically it works based on a comparison where each adjacent pair of element is compared and swapped if they are not in order. So let's say, to make you understand this first statement, bubble sort is based on comparison where each adjacent pair of element is compared and swapped if they are not in order. So let me explain you this first point with an example so that it will be easy for you to understand. In the same way, what I want to do is, so let's say I'm going to have an element like this, so the elements are, let's say, 50, 40, 30, 20, 10. Now the elements are arranged in a descending order. Let's say I wanted to arrange this element in an ascending order using bubble sort algorithm. How am I going to do that? So let's consider this is an array. So when I say this is an array, so the array is going to look like this. In the 0th index, the value 50 will be stored. First index 40 will be stored. The next one will be 30, 20, followed by 10. So this is the 0th index, first index, second index, third index, fourth index. Now, how many number of elements do we have them here? So the number of elements that we have them here is 5. I hope you can see, right? So we have 5 elements. Originally, these elements are arranged in a descending order. Let's say, using the bubble sort algorithm, I want to arrange these elements in an ascending order. So let us go back to the theory to understand what is bubble sort. Bubble sort is based on a comparison where each adjacent pair of element is compared and swapped if they are not in order. So in this same example, we have 5 elements. If you wanted to arrange these elements in an ascending order, you don't have to sort all the elements. You are required to sort only 4 elements out of these 5. in the sense fifth element will be placed on its correct position on its own. So when you have 5 elements, you don't have to sort all the 5 elements. You are required to sort only 4 elements, which means fifth elements will be sorted automatically. So in that case, we are going to compare both. As you can see them here, we are going to compare each adjacent pair of elements. So when I say each adjacent pair of elements, I'm going to compare these two, these two, these two and these two. This is an adjacent pair of elements. So using bubble sort, let me show you how are we going to sort these elements that are in a descending order to an ascending order. So the first step here, I'm going to say, in the first step, let me take the actual array. This is 50, the next one is 40, 30, 20, this one is 10. So first I'm going to compare this 50 with 40. So when you compare 50 with 40, which one is greater? 50 is greater than 40. So when you compare these two, if left side is greater than the right side, then we need to swap, because we are trying to arrange this element in an ascending order. So when you compare 50 with 40, what will happen? 40 is less than 50, so I have to swap these two numbers. So when you swap these two numbers, in the next step, what will happen? So here, when you swap this one, 40 will come here, 50 will go there, then 30 will be here, 20 will be here, then 10 will be here. Okay, so first we have managed to compare these two. In the second step, we need to compare these two. When you compare these two, 50 is greater than 30. When 50 is greater than 30, what do you need to do? You need to swap these two. So in that case, what is going to happen? So here, the 40 will remain here. I'm going to swap 50 with 30. So 30 will come here. 50 will go there. 20 and 10 will remain there. So in the next step, what do I need to do? First, we compared these two. In the second step, we compared these two. Third step, we need to compare these two. When you compare those two, what is going to happen? The 40 will be just here. 30 will be just here. Now we are comparing 50 with 20. So in that case, 20 is smaller than 50. So 20 would come here, 50 would go there, and then the 10 will remain there. Now what is next step? Next step is to compare these two. When you compare these two, what will happen? 40 will remain here, 30 will be here, 20 is here. Now when you compare 50 with 10, 10 is smaller than 50, so the 10 would come here, 50 would go there. So in that case, we are successfully managed to sort this element 50, because 50 is the highest element, so it has to be there at the end. So now we have managed to sort one element from this whole element. So the next step, we have managed to sort the one element. Now we are remaining with what? We are remaining with 4 elements, that are what? 40, 30, 10, 40, 30, here is 20, the last one is 10. I'm not going to include this 50 here, because 50 is the highest element. It is already there at the far end, so I don't have to do anything with that 50. Now in this array, I have only 4 elements. At first I have 5 elements, so I have managed to sort one element out of 5. So in the next step, we are going to have only 4 elements. So now what do I need to do? I need to compare these two. When you compare these two, 30 is less than 40. So here what is going to happen? 30 will come here, 40 would go there, this is 20, this is 10. So what is next? You have to compare these two. When you compare those two, what is going to happen? 30 will be just there. When you compare 20 with 40, 20 is less, 20 will come here, 40 will go there, then 10 will remain there. Now we are going to compare these two. When you compare those two, 10 is less than 40, so it's going to be 30, 20, 10, 40. So the array is going to be like this. So in that case, first we have managed to sort the number 50. In the second step, we have managed to sort the number 40. Now we need to sort only these three elements. So this one I will say, this is first pass. During the first pass, I managed to sort the first number. So this is a second pass. During the second pass, I managed to sort the second number. Now I am going to do the third pass. So in the third pass, I don't have to pick 40 because 40 is already there at the fore end. So I'm now going to pick the remaining numbers 30, 20 and 10. So in this 30, 20 and 10, first I'm going to compare these two adjacent elements, 30 with 20. 20 is less, the 20 will come here, 30 will go there, 10 will be there. I hope it's making sense. So in the next time, I'm going to compare this 30 and 10. In this case, 10 is smaller, so it's going to be 10, 20, 10, 30. So at the end of third pass, we have managed to sort the third element, that is 30. So the next one is a fourth pass. Sorry, just a minute. So let me use the fourth pass here. So in the fourth pass, what I have them here is only 20 and 10. So I'm going to pick this. This is going to be what? 20. This is 10. Compare these two. 10 is smaller, so the 10 will come here, 20 will come there. So in short, we had 5 elements, but we were using only 4 passes to sort 5 elements, isn't it so? Now if you can look at this element, the first one is 10. The 10 is found in the 0th index, 20 is found in the first index. When you go down there, here 30 is found in the 3rd index, 40 is found in the 4th index, 50 is found in the 5th index. So as a result, we have managed to sort the array as 10, 20, 30, 40 and 50. Isn't it so? So now we have managed to sort these elements in an ascending order using Babu sort. Babu sort, we are going to compare each adjacent element. Then if this element from the left is greater than the right one, we are going to swap, in case if you want to sort the items in an ascending order. So that is about the first point. So it works by repeatedly stepping through the list to be sorted, comparing two items at a time and swapping them if they are any wrong order. I think that is exactly, we were repeatedly comparing until we find the correct order. So the last point says the pass through the list is repeated until no swaps are needed, which means the list is sorted. Exactly, there is no swaps that are needed here because the lists that you can see them here is already sorted. So this is exactly what Babu sort is. Now let me just show you how we can implement a C programming function to perform this Babu sort. I hope now you get the concept. In case if you have any questions, you are free to ask. Otherwise, we just have to compare. So first pass, compare these two first, then swap. The next one you compare these two, the third one you compare these two, the fourth one you compare these two. Then automatically one element will be sorted. In the second pass, this one is already sorted, so just pick this part that you can see them here, 40, 30, 20, 10. Compare these two. In the next pass, compare these two. In the third pass, compare these two, right? And then the fourth pass, just pick the third pass, just pick the ones that are not sorted. So this one, compare these two, then it will come here, it will go there. The next step, compare these two. So the array would be like that. In that case, index number 3, that is 30, which is already been sorted. In the fourth pass, pick this array 20 and 10, compare these two, 10 would come here, 20 would come here. So if you look at the whole structure, it is going to be 10, 20, 30, 40, 50. We have managed to sort this element in an ascending order. I hope it's making sense. Now, as I said, when you have 5 elements, in this same example, we have 5 elements. We had only 4 pass. First pass where we can able to sort one element. Second pass we can able to store the second element. Third pass, third element. Fourth pass, fourth element. So when you sort 4 elements out of 5, which means the 5th element will be sorted automatically. So you don't have to sort that one, right? So when you have 5 elements, we are going to sort only 4 elements. When you have 10 elements, we are going to sort only 9 elements. Keeping that thing in mind, let us write a simple C programming function to understand this babu sort. So let me remove everything. Okay, so now let me just draw the array here. Let me pick this one. So let me just draw the same array here. So this is 50, 40, 30, 20, 10. So this is 0th index, 1, 2, 3, 4. Let me just draw the first pass alone. So I'm sure that you can able to see. So here in the first pass, it will become what? 40, then 50 will go there, 30 will be there, 20 will be there, 10 will be there. I hope you remember, right? Now again, in the next pass, what is going to happen? 40 will be here, 40 will be here. So this 50 and 30 will be compared. 30 will come here, 50 will go there, 20 will be there, 10 will be there. So in the next pass, 40 will be here, 30 will be here. We are comparing these two. So in that case, 20 will come here, 40 will go there, 10 will be there. In the next pass, 40 will be here, 30 will be here, 20 will be here. We are comparing these two. In that case, 10 would come here, 50 would go there. So we have managed to sort the 50. Now we are going to write a C programming function. So if you consider the whole thing, here we have column, here we have row. These are rows, these are columns. So I need a nested for loop for me to sort these elements using a babu sort. So for that, I'm going to have a nested for loop. So the nested for loop, outside for loop. So outside for loop which represents the row. When I say row, this is row, right? So let me say, I'm going to say I equals 0 because that is a 0th index, comma I less than, let's say in this case we have 5 elements, isn't it? So 1, 2, 3, 4, 5. When you have 5 elements, how many passes did we have? Only 4 passes. What does that mean? When you have 5 elements, you can sort only 4 elements so that the 5th element will be automatically sorted, isn't it so? So when you have n elements, you don't have to sort all the elements. It's going to be n minus 1. Why n minus 1? When you have 5 elements, you sort only 4 elements, the 5th element will be sorted automatically. That is the reason why I had to say yes. Starting from 0th index, n represent the number of elements. Again, minus 1 simply represent you don't have to sort all the elements, because when you sort n minus 1, the whole element will be sorted. So the next one is going to be what? I plus plus. So this for loop simply represent the row of this particular element. Now I have the column because I need to compare In the first pass, I need to compare these two. The second pass, I have to compare these two. Third pass, I have to compare these two. Fourth pass, I have to compare these two. Isn't it so? For the same, inside, I'm going to have another for loop, that is here. I'm going to have another for loop. I'm going to call this one as j is equals to 0. Again here j is also going to be n minus 1, and then this is going to be what? J plus plus. So this one simply representing the column of this particular array. Now what are we going to do? I'm sure that you still remember. Now we have the row and column. What is next? We need to compare these two. Isn't it so? We need to compare these two. So how are you going to compare? Let's consider this one is an array. Okay, let's consider this one is an array. So the array, I'm going to say them here is what? So I'm going to say this is array of this j is greater than array of j plus 1. What does that mean? I'm simply saying this is array of j, this is array of j plus 1, because array of j represent the first position, j plus 1 represent the second position. Now I'm comparing array of j with array of j plus 1. In that case, the first element is 50, the second element is 40. I'm going to compare with this one with the if condition. Is it true or false? Condition is true. If the condition is true, what do you need to do? You need to swap, isn't it so? The 40 should come here, 50 should go there. I'm sure that you know the function for you to swap two numbers. So first I'm going to create a temporary variable, and in that temporary variable I'm going to store this array of j. Okay, I think this is simply a simple swap function that you usually use in C program. So next one is going to be array of j is going to be what? Array of j plus 1, and then array of j plus 1 is going to be what? Temp. That's it. So this is a function that is going to help us to swap this element or to sort this element using babu sort. So let me explain you this one. So when the I value is 0, I n minus 1. What is n here? N is 5, right? So what is I value? 0 minus, what is n value here? There are 5 elements. 5 minus 1 is 4. 0 less than 4. Is it true or false? The condition is true. When the condition is true, the control will come inside the for loop. Inside the for loop, I have said j is equals to 0. Then j less than n minus 1. What is j value? 0 less than n minus 1. What is n? N value is 5 minus 1 is 4. I will come inside. Now I am going to check array of j is greater than array of j plus 1. Array of j is what? 50, greater than 40. The condition is true. If the condition is true, I will come inside. So I have created a variable name called temp. Is going to store the array of j. What is array of j? Array of j is what? 50 here, right? In the second step, array of j is going to be array of j plus 1. What is array of j plus 1? This is array of j. This is array of j plus 1. So in simple terms, this 40 would be stored into array of j, isn't it so? In the next step, array of j plus 1, array of this j plus 1 is what? Temp. What is the temp value? Is equals to 50. What does that mean? So array of j value will be 40. This is array of j value. This is 40 now. Array of j plus 1 is 50. We have managed to swap these two numbers, right? Now again, what will happen? This is for loop, meaning is going to be executed as long as the condition is true. Now we are going to increment the j. We have two for loops. So this inner for loop will be executed until this particular condition will become false, right? So I'm going to increment the j value. What is the j value? Before it was 0, now it will become 1. 1 less than 4, condition true. If it is true, it will come inside. Now what is the j value? J value is 1, isn't it so? What is the j value? Array of j. J value simply means what? Now the j value is 1. What is array of 1 here? So here this is 0, this is 1, 2, 3, 4. When I say j value is equals to 1, it simply represent 50, right? Simply represent 50. Greater than j plus 1. From here plus 1 is what? 2. What is the value there? 30. So compare these two. The condition is true. When the condition is true, what are we going to do? We are going to swap. As a result, here we have managed to swap. 30 has come here, 50 has gone there. Again, the j value will become what? 2. 2 less than 4, condition true. So meaning j value is 2. In this case, j value is 2. J plus 1 is 20. We are going to compare 50 with 20. Condition true. We are going to swap. And then the next case, j value will become 3. 3 and 4 we are going to compare. In this case, 50 and 10 will be compared. Condition true. We are going to swap. Right? We have swapped. Now the j value will become 4. 4 less than 4. Condition is false, isn't it so? 4 is not less than 4. 4 is not less than 4. In that case, condition is false. When the condition is false, this inner for loop will stop its execution. It will come outside, then it will go to the outer side for loop. Only we have failed the inner for loop, but the outer for loop is still there. Now we are going to increment the I value. What was the I value before? 0. When you increment it by 1, the I value will become 1. 1 less than 4 is true. It will come here. Again, this for loop is going to be executed. Now, j value is 0. Yes, j value will start from 0 less than n minus 1. Remember, in the first pass, yes, we are taking all the elements. If you could remember correctly, in the second pass, we were not considering this 50. We took only 40, 30, 20, 10. We didn't pick the 50 in the second pass. Why? Because this 50 is already in the right position. So I don't have to sort it. So in that case, here when it comes to the second pass, yes, j value is 0, n minus 1 is 4. Here 0, 1, 2, 3. But my index number is 3. But according to this particular condition, my index number I can go up to 4. But there is no need for me to go up to 4 because the fourth element is already been sorted. So in that case, what do I need to do? So this 4, I need to reduce it to 3. If you have to reduce it to 3, what do you need to do? We are simply going to say n minus 1 minus what? I. What is this I? I value is 1. So every time when the I value increases, this I value will also be increases. So the next time we don't have to go up to 3. We will go up to only 3, isn't it so? So 0, 1 and 2. The final one will go only 0 and 1. If you could remember, this one will become 10, 20. This one will become 20, 10 and 30. This is how it is, right? So every time the size of an array is reduces based on the I value. That is the reason why I had to put the I value here. So this is basically a C programming function for us to do the bubble sort. I hope this is clear. In case if you have any questions, you are free to ask me. This is the first sorting algorithm that we have in data structure, that is bubble sort, where we are going to compare each adjacent pair of elements. And when you compare, as you compare, if the left side is greater than the right side, in case if you wanted to sort the element in an ascending order, you are going to swap. In case if it is already in order, you're not going to swap anything. So this is basically bubble sort. If you have any questions, you are free to ask me. Thank you.